All right, these are the fun ones. The first one we're looking at here, notice it's a mix of secants and cosecants. What I'm going to have you do here is we want to split those up. And one way that we can split those up is by factoring. Did you think I was going to say that word there? We're going to factor by taking out a GCF. So if you look here, they both have a cosecant in common. So I'm going to factor out a cosecant. So I've got cosecant theta. If I divide out cosecant, I'm left with secant theta minus 2, because I already divided out that cosecant. All right, so now I have two factors here. I've got cosecant theta is equal to 0. I'm going to set them both equal to 0. And I've got secant theta minus 2 equals 0. Add 2 to both sides. So I've got secant theta is equal to 2. All right, so I know these are not the ones we usually like to work with. So I'm going to change secant into sine because reciprocal cosecant is sine. If I flip 0 over 1, that's going to give me 1 over 0, which think about what 1 over 0 means. That is undefined. Think about what sine means. Sine is my y value. So my y value is undefined. All right, another thing I want you to kind of look at, let me get this first quadrant back here. The only time you're going to have ones and zeros is on our quadrantal angles. Quadrantal angles, I can't ever say that right. But my y value here is 1. My y value here is 0. You're never going to get a y value to be undefined. So really, you don't even need to worry about this. You don't need to do any work because it's not possible. All right, so I can ignore that. I'm done with that. Good news. If that would have been tangent, then I'd have to do some work because tangent means, we could do 1 over 0. All right, let's jump over to secant. The reciprocal of secant is cosine. So if I flip 2 over 1, that's going to give me 1 over 2. Remember what cosine means. Cosine is my x value. So I want positive x values here. Let me graph this. And remember where x's are positive. They're positive to the right. So I'm going to draw half of that bow tie because that's where my x values would be positive because it's going to the right. All right, so if my x value is 1/2, going over a half, that would mean that my y value would have to be radical 3 over 2. So if you want to use the hand, I need a 1 on the left. So if I put that down, that's going to give me my 60-degree finger. If you don't like the finger or the hand thing, no big deal. Look here. Where do we have the ordered pair 1/2 radical 3 over 2? At pi over 3, 60 degrees. So my reference angles are pi over 3. I'm going to get 2 answers here. Remember what I said about the first quadrant? That should be easy. It's just whatever the reference angle is. So my first answer is pi over 3. The second angle is going to almost go around a full circle. So think about what a full circle is. That's 2 pi. Since I'm dealing with thirds, I'm going to change that to 6 pi over 3. It doesn't quite make it that far, so I'm going to do 6 pi over 3 minus pi over 3, and that's going to give me another answer of 5 pi over 3. So we could have actually ended up with more answers, but since that y was undefined, I didn't need to do anything with that. All right, take a look at the next one. Tangent. Again, we've got tangent twice. They're not like terms because this is tangent cubed, so I can't just put those together, but I can go ahead and factor out a GCF again. All right, so I'm going to divide tangent from both of those terms. So I've got tangent. I'm going to be left with 3 tangent squared theta minus tangent divided by tangent is 1. So now I'm going to set both of these equal to 0. So I've got tangent, oops, I should have put a theta right there. Tangent theta is equal to 0. And then I've got 3 tangent squared theta minus 1 equals 0. So I've got 2 problems to do now. tangent is 0. Let's start with this one. Remember what tangent means. Tangent is sine over cosine. It's y over x. When are you going to divide to get 0? Let's look at our first quadrant here. The only time you're going to get 0 is if you use one of these quadrantal angles. So it's just a matter of which one do we use. A lot of times I like to just make a graph and check it out. This ordered pair right here goes over 1, up 0. So if I did 0 divided by 1, does that give me 0? Yes. So that's going to be one of my answers. I'm just going to kind of circle that. I'll come back to it. Up here, I've got the ordered pair. It goes over 0, up 1. If I did 1 divided by 0, that's going to give me undefined. So that one doesn't work. I don't want that one. Over here, this is the ordered pair, -1, 0. If you do 0 divided by -1, will that give you 0? Yes. So there's another answer. I'll just have to figure out what those are in a second here. And then here I've got 0, -1. Again, that would be undefined, so I don't want that. All right, so how big are these angles here? Notice, way back at the top there. Okay, I don't want you to tell me 2 pi is an answer. That's why it just says less than. So this would be the angle 0. So theta is equal to 0. Yes, it's also 2 pi, but because of the directions, we're not going to put 2 pi. Here, that is pi. So 2 of my answers so far are 0 and pi. So that's very similar to when we did the quadrantal angles. We're not done. We still have to mess with this here. All right, so I've got to get that tangent squared by itself. Do you remember what happened when we had squared before? With this example, whenever you take the square root, you get plus minus. I hear some of you guys moaning, like, ooh. Okay, so what I'm going to do is I'm going to add 1 to both sides. I've got 3 tangent squared theta equals 1. Divide both sides by 3. We're just doing algebra here. It's just weird looking algebra. Tangent squared theta equals 1/3. To get rid of the square, use square root. Whenever you take square root, you're going to have to make sure you do plus or minus, so don't forget about that. So tangent theta equals plus or minus, the square root of 1 is 1, the square root of 3 is radical 3. I know I can't leave it like that, but for now I am, just because I know that tangent means y over x. So I need to figure out what kind of ordered pair is going to simplify to give me 1 over radical 3. If you go back and you look, it's going to have to be one of these that pairs up 1/2 with radical 3 over 2. I want the top to be 1, and I want the bottom to be radical 3. So the only way that's going to happen is if my y is 1/2 and my x is radical 3 over 2. All right, so let me graph this. Remember, it's plus or minus, so I'm going to have to make all 4 of those bow tie, the whole bow tie. All right, so once you get all 4 of your triangles, I know my y is 1/2. If the y value is 1/2, that means we're going to have a 30-degree angle, or pi over 6. So pi over 6, all of these reference angles are pi over 6. And then we're going to use those to find our angles. And again, we made all 4 because it was plus or minus. Over here, I'm going to label that as pi, since we're dealing with a 6. I'm going to change that to 6 over 6. And then a full circle would give me 2 pi. All right, first angle right there. Should be easy. I'm going to put this up here with these other answers. I've got pi over 6. The next angle is going to not quite make it to 6 over 6. So if I did 6 pi over 6 minus pi over 6, that's going to give me 5 pi over 6, my next answer. All right, the next angle is going to go past 6 pi over 6. So if you need to see the work, that would be 6 over 6 plus pi over 6, and that's going to give me 7 pi over 6. And the last one is going to almost make a full circle. A full circle is 2 pi. If I want to change that to 6, it would be 12 over 6. It doesn't quite make it there. So if I do 12/6 minus pi over 6, That's going to give me 11 pi over 6. All right, so I kind of squished all those answers in here. So this problem actually ended up with 6 answers because we had the plus minus, and then we had those 2 quadrantal angles. Oof, that's a little scary looking. All right, one more, and I'm going to do this one on a different video. Just, you'll see. Okay,